Proving segment relationships. What do we know about segments? Well, we know that if you have a segment, it's got two endpoints. We also know that if you put a point between the two endpoints, that we have a relationship between three different segments. So I have, if I call this A, B, and C, I have segment AB plus segment BC is equal to the whole segment AC. So AB plus BC equals AC. And this is called the segment addition postulate. The segment addition postulate. So I will often write it, because I'm an abbreviator, seg plus post. And we also only have little bitty lines to write the answers on. So we know the segment addition postulate. We also know that if you have two segments that are congruent, so if segment AB is congruent to segment CD, we know that the length of segment AB equals the length of segment CD. And this is called the segment congruence definition, or the definition of congruent segments. Okay, so we know that. What else do we know? We also know all of the properties of algebra, and since we have a little addition situation right here, we might be able to use those properties in a proof because we have equations here. All right, so we know all of or we have them in front of us still, all of the properties of algebra. We can refer to those properties for some of the proving segment relationships. All right. If I go back to this first page, that is the segment addition postulate. And I can look at that and write this because of this. All right, so I'm going to go back. Okay, we are going to prove that if segment CE is congruent to segment FE and segment ED is congruent to segment EG, then segment CD is congruent to segment FG. And there's a picture of that so that you know what I'm talking about. All right, segment CD and segment FG with intersection at E. All right, so we have a little situation that we're going to prove. So we want to set up our proof. The first thing we do is write down the word given, put a little colon, and we write our word prove. We make our two columns. We have our statements and our reasons. Okay, so we're going to write what our given information is. That comes from the if part. Okay, so the given information comes from the if part. And that would be if CE is congruent to FE and segment ED is congruent to segment EG. Okay, so we write that in our given. So if segment CE is congruent to segment FE and segment ED is congruent to segment EG. We want to prove, and we're going to prove whatever is in the then part. Then CD is congruent to segment FG. Okay, we've got it all set up now. Okay, so when you have a proof and you're gonna start writing it, and you have given information about a figure, I think but first it's really great if you start with your figure and mark it up to what you know, so that you can see and visually see what's happening. So I'm given that CE is congruent to FE. So look over at CE. It's congruent to segment FE. So mark those congruent with tick marks. Then I want to look at ED. ED is right here, and it's congruent to segment EG. So mark that, and you can see, well, of course CD is congruent to FG because they're made up of things that add up together that are the same, right? And this may seem like, well, I don't know how you're supposed to write this because it's really super duper obvious. But again, we're starting off with easy proofs because we're starting off writing proofs. All right, so I'm going to start my proof now, and I'm going to write down what I'm given because I'm always going to write that first. And I just write number 1, and then I just list what I have. So I have CE is congruent to FE, and I have ED is congruent to EG. And my reason is given. So that you always should be able to get those right. Okay, so there's nothing that I can do with that information yet when segments are congruent, but I do know that segment addition postulate, if I have the lengths of the segments. So I'm going to turn these into segment lengths versus segments, okay? So I'm going to say because CE is congruent to FE, I know the length of segment CE equals the length of FE. Same with the length of segment ED equals the length of segment EG. And I know that because that's the definition of congruent segments. Okay, I'm going to move this up so we have more room, but I'm not going to hide the given or the picture, just the statement. Okay. So if I think about this for a minute, and I have segment CE plus ED, and that's equal to the whole segment, and then I have FE plus EG equals to FG, and I can start replacing like the ED with the CE or something, substituting it. I can make those equations be the same and make them and prove that the two segments are congruent. So let's do that. I'm going to write that CE plus ED equals CD. And I know that because I can look at that picture and know that. Okay, that's like a visual, like I can see that. Also, I can say that about the FE plus EG equals FG. So how do I know that? What rule would I put? What justification? And write segment addition postulate. Since CE is equal to FE, I could rewrite this equation and replace the CE with an FE because they're equal. So FE, now I'm rewriting this first equation, okay? FE plus, well, ED is equal to EG. So instead of writing ED, I'm going to write EG. But CD equals itself, I mean, CD doesn't have anything, so I'm not substituting anything else. So here, for number 4, why was I allowed to rewrite that equation? Why was I allowed to rewrite this equation using the FE and the EG?
Because the lines are congruent.
Exactly. And so there's a property of algebra that allows me to replace something with something else, and it's called substitution property, and that's what I used. So if you abbreviate substitution, do not write sub, because there's subtraction also. So you have to at least write substitution, like, because subtract would be SUBTR, so substitution property. Okay, so now look, I have here on my proof, I'm going to move it up a little bit, that FE plus EG equals FG. I also have that same 2 segments added together equals CD. So can I rewrite this equation right here, but instead of writing FE plus EG, substitute it with the CD? Because they're equal. So here I'm going to rewrite this equation here, substituting the FE plus EG with CD. Again, that's a substitution. And I'm trying to prove that segment CD is congruent to segment FG. And I have that their segments are equal, so I can now write that they are congruent because congruent segments have equal lengths. And that's the definition of congruent segments.